In Algebra 2, we are going to start in with quadratics here in Unit 3, which I've been warning you about all semester long. And with quadratics, the main thing is that the exponent is 2. So the quadratic term is the x squared term. They have this little caveat on here that the a value, the number that's in front of x squared, cannot be 0. Otherwise, it would just be like a straight line, y equals mx plus b, except we use in alphabetical order a, b, c. So get used to this quadratic form. We call the first term the quadratic term. And yeah, they just want to remind you how to evaluate without a calculator and to remind you to do the order of operations. If you do this wrong, you will mess up probably the rest of the unit, and it's the long one, so make sure you get this. Because if you remember in the very first lesson, we talked about how when you square a negative, you have to multiply by itself. So make sure that you get a negative times a negative is positive 9. I'm taking for granted that you remember that this is function notation, so you're just replacing the x with negative 3. Next one's not as big of a deal because when you square a positive in a calculator, you'll get the right answer. 5 squared is 5 times 5 is 25. So that holds true with the next one as well, that plugging in 2 is not that big of a deal with the use of parentheses. So as a reminder, you do 2 squared first is 4 times this 2 is 8 minus 5 equals 3. Double check my arithmetic, okay? Because the next one, as soon as you square the x, so once you square negative 1 times negative 1 is positive 1. And so when you get 2 times 1 is 2 minus 5, still part of the problem, 2 minus 5 is negative 3. So I can't emphasize it enough that in function notation you're replacing, but when you square negative 2 you get positive 4. This negative is still there. And then 4 times negative 2 would give me negative 8. Just trying to write a little bit less. So negative 4 plus negative 8 gives me negative 12. And then same thing with 3, that's substitute in there. Well, 3 when you square it is 9, and then you negate it. And then 4 times 3 is 12. Negative 9 plus 12 is positive 3. So the reason why we need you to get on board with how to do this is you can always make a table of values in order to graph a function. So I want you to think about what the parent function of this looks like. And in case maybe you've learned this in Algebra 1, these are called parabolas. Parabolas. And the easiest one to talk about is just x squared. Because if we go through it, it's actually the same thing as f of x that was up here. And when we squared negative 3, remember we got 9. Negative 2, once you square it, or square here, you get positive 4. Negative 1 when you square, negative 1 times negative 1 is 1. And at any point, you can always pause the video and think about what these ordered pairs look like. But yeah, you can plot the ordered pairs. 1, 1, negative 1, 1, 2, 4. And then 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. And you need to connect the dots. Now notice, and I'm not an artist, but hopefully you're realizing that these are supposed to be curved. They are not directly touching. I mean, they are touching all the points, but not in a straight line. So in this problem, we have what is called a turning point. So what do I mean by turning point is where it changes from going down to going up. Maybe another way of saying it is it changes from decreasing to increasing, but it doesn't have to be decreasing to increasing. A turning point could be from increasing to decreasing. I should have wrote that down and then said it, but that's okay. The math term that we use for this is what's called the vertex, and the ordered pair would be 0, 0. So I want you to get used to both the phrase turning point and vertex. And then there's one more thing, and it's called the axis of symmetry. I don't know if you're aware, but the word axis actually means line. So it's a line of symmetry. And because, let me write this in a different color, because this axis of symmetry is a vertical line, we always write it as x equals, because x equals is a vertical line instead of a horizontal line. Oh, let's write it out. And what does it mean to be symmetrical is that they're reflected. In this problem, it's reflected across that line. You see how this negative 3, 9 is 3 units away, and then this 3, 9 is 3 units away. That's what it means to be symmetrical. And it's x equals 0. And notice that it's the same x-coordinate that passes through the vertex. So the axis of symmetry passes through the vertex. That's important, so I'm going to write that down. The axis of symmetry passes through the vertex. And that is true of all parabolas, of all quadratics. So as I move on to the next one, we're actually going to use a graphing calculator, as it asks us to, and use the table feature to determine where the turning point is located. So you have to think a little bit after typing into your calculator. So hit that Y equals button if you have access to a graphing calculator, otherwise you just might be following along. Plus 6x plus 5, and then you can hit second graph and examine what your table looks like. So what would make something be the vertex is, you see how I'm increasing first. I'm looking at the y values, I should clarify. I'm going up, and then I start to go down. Now if you didn't know that that was where we're turning, you can always plot these points, like 0, 5, 1, 10, which I believe they're asking you to do over here, which they, I don't know if they did this on purpose to make this, let's just make right here the origin 0, 0, because it started up 5, 1, 2, 3, 4, 5, and then what was the next point? I already forgot. 1, 10, 2, 13, so 6, 7, 8, 9, 10, 2, 11, 12, 13, 3, 14, and then I know this because I've played with this a little bit, so I guess I'm already doing part C without thinking about it, but I think sometimes part C might help you understand part A. And again, I want you to get used to that word vertex was at 3:14, if I remember correctly. Let's look at my table again. 3:14, good. Yeah. And that's where my y value, in this case, because remember in exercise 2 it changed from decreasing to increasing. This time it changed from increasing to decreasing. And you probably noticed that I also picked out this point and reflected it over, and this time my axis of symmetry is this vertical line. Now it's still a vertical line, and if you remember that shortcut I mentioned before, it's always the x-coordinate of the vertex. I should write down V for vertex. And we already did part C. It also wants all intercepts and turning points are shown. Right now I'm missing some of my intercepts and turning points. But the question on the next one is, why is this opening downward as opposed to opening upward? Because remember that y equals x squared was opening upward. And this one you might not know, so I'm just going to have to tell you. It's all based off of the a value. So remember we talked about y equals ax squared plus bx plus c. If that a value is negative, that's going to be my clue that we open downward. So let me circle that. And I kind of messed up my graph, but hopefully you can forgive me. Between what two consecutive integers are the larger of the zeros? Because if I extended my graph down, we might be able to answer by looking at this, or we can use a graphing calculator. Since we have a graphing calculator, we have our table feature. Well, the only way to cross from 5 to -2 is if we hit 0 somewhere in there. And if you aren't on board with that explanation, you can hit the graph key and you can count over. 1, 2, 3, 4, 5. Bigger than 6, but smaller than 7. So between, I thought I changed colors, but apparently not, 6 and 7. And showing that point on the graph was supposed to be about right here. 1, 2, 3, 4, 5. Right here is 6, and right here is 7. And we have a few more things to point out. And we have the sketch of this quadratic, except they don't give you enough information. But they marked a few points, its intercepts, its turning point, and wants you to use the tables on a graphing calculator to determine the coordinates for each of these. So we're practicing some more with our graphing calculator and just examining what's going to happen. So I'm going to go back to y equals. You can hit the delete key to get rid of stuff. You can type over, or you can hit second insert to insert a few things. Play around with your calculator, see if you can figure it out. And the issue I have is if I just go back to my graph, I don't quite see enough information. So you have a few options. You can just zoom. The third option is out. You have to enter one more time. But even then, that's not a very good graph. So what you might do is just change your window. It looked like -5 was still an okay value for your x, but maybe you just want to go to 20 over there. Now, my y min didn't quite get down to everything, so maybe you go down to -50, but it looked like my y max was fine at 5. Oh, didn't quite get my y min, so I can change that again, -60 maybe. Go to my graph. And maybe now you can get a better feel of where everything's at. You can count to the left 2. You can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And you can also find these points. And you can also use your table and play around. Oh yeah, when x was -2, I got y equals 0. When x was down to 13, I got y equals 0. So that's at least a few things. That a is the ordered pair -2, 0. I'd be fine if you just wrote a equals -2. Same thing with the b value. That's the ordered pair 13, 0. B would equal 13. Now remember, the y-intercept occurred when x equals 0. Now, as far as a y-intercept goes, you might just look on your table. You might plug in 0 in for these x's. And again, I'm fine if you just write c equals -26. Now, I do want to point out how you can use a graphing calculator to actually find the exact vertex. And it's hitting second trace. And because it's the lowest point, you want to hit minimum. So it's the third option. And this is kind of weird. You have to hit enter to the left, enter to the right of that vertex, and then closer. So it's 5.5, -56.25.